Okay, in this video we're going to talk about using determinants to solve systems of equations. So let's talk about what is a determinant. The determinant of a 2 by 2 matrix is calculated D for determinant. All you do is take A times D and subtract B times C. So the determinant is just AD minus BC. So it's pretty simple to calculate. You have to be careful with your signs though. So if I want the determinant of this matrix, I'm going to do 2 times minus 3 minus 5 times negative 1. Well, that's going to give me minus 6 minus negative 5, which is minus 6 plus 5, which is negative 1. If I want to calculate this determinant, minus 1 times 1 minus 3 times 2 would be minus 1 minus 6, which is negative 7. And then if I want to calculate this determinant, minus 2 times minus 3 minus 6 times 1 would be positive 6 minus 6, which is 0. So be careful with the calculations. They seem simple, but the minus sign can get you. Okay, so Cramer's rule is a method that uses determinants in order to solve a system of linear equations. Now, when you see these vertical bars right here, this just means we're going to get the determinant of the matrix. So if I want the determinant of a matrix, you'll see those vertical bars. So the formula for Cramer's rule, if you have two equations where you have ax plus by equals m and cx plus dy equals n, then x is simply going to be a determinant on top over a determinant on bottom. Now the determinant on bottom in both of these, whether you're solving for x and y, is just the determinant of the coefficients a, b, c, d. The determinants on top are actually, for x, the first column are the constants m and n, and the second column are the coefficients of y. And for the y value, the first column is the coefficients of let's see, x, and this should say c here, not b. So coefficients of x, and then the second column is the constants. So, down here I have a system, and we can solve this easily using determinants. So if I take the top, if I solve for x, the top's going to be the coefficients of y, which are, the top's going to be, the first column's going to be the constants 3 and 5, and then the second column's going to be the coefficients of y, which are negative 3 and 2. The bottom's just the coefficients of the variables 2, negative 3, 1, and 2. Now, calculating this determinant, I get 6 minus negative 15, which is 6 plus 15, or 21. And on the bottom, the determinant would be 4 minus negative 3, which would be 4 plus 3, which is 7, and 21 divided by 7 is 3. Now, for y, the first column is going to be the coefficient of the x values, and then the second column is going to be the constants. And so when I do this determinant, I get 2 times 5 minus 3 times 1, so that's 10 minus 3, which is 7, and the determinant on the bottom is the same as I had up here, so its value is still going to be 7. So I'm going to have 7 over 7, which is 1, and so the solution is 3, 1. Now, go ahead and pause the video and work through number 2 and see if you can get the answers I got down here, negative 155 over 11 minus 60 over 11, working it just like I did number 1. Now you will notice on number 2, I calculated the determinant of the coefficient first because there was no reason for me to have to calculate that twice since it occurs in both the x denominator and the y denominator. Now number 3 is a special case because on this one, if you calculate the determinant of the coefficients, you're actually going to get 0. And if you get 0 for the determinant of the coefficients, that tells you that there's not a unique solution. Now, this is a shorthand notion that can be used, but basically it's exactly the same thing I just did. So if you'll notice up here, I said x equals this fraction and y equals this fraction. Well, here x is the same thing. Dx was what I had on the numerator for x, and d is what I had on the denominator for x. And then dy was what I had on the numerator for y, and d is what I had for the denominator of y. So, basically I'm doing the same thing. It's just a shorthand notation to write the answer. So if I take this system here and I wanted to solve it, well, we know we're going to need d, the determinant of the coefficients. So I take the coefficients here, 5, 3, and then I subtract negative 3 times 2, and that's going to give me 15 plus 6, which is 21. Now, to calculate dx, I'm going to take negative 1, 8, which are the constants, and then negative 3, 3 are the coefficients of y, and I calculate that determinant, and that's going to give me minus 3 plus 24. Remember, you're subtracting, so the sign changes to plus 24. So minus 3 plus 24 is 21. And then to get dy, I take 5, 2, which is the coefficient of x, and then this column is going to be the constants, negative 1, 8, and then I multiply here and subtract this product, so I get 40 minus negative 2, which is 40 plus 2, or 42. And then using these notations up here, I get x is 21 over 21, which is 1, and y is 42 over 21, which is 2. So the solution is simply 1, 2. Now, to solve a system of 3 equations and 3 variables, we would need to know how to find a third order determinant. So basically, that says discriminant, it should say determinant. So the third order determinant, basically you take A1 times B2, C2, BC3, C3, that determinant, minus A2 times B1, C1, B3, C3, plus A3 times B1, C1, B2, C2. And down here's what happens if you actually calculate those determinants. I'm going to actually show you a quicker way to calculate this determinant, or an easier way to calculate this determinant in the next example. So let me just go ahead and get that set up for you. Okay, you may have noticed this, but if you didn't, basically the first step is to take this top entry in the first column, 4, and multiply it by a 2 by 2 determinant. But notice the 2 by 2 determinant actually comes from, if you'll just go ahead and mark out everybody that's in this row that contains the 4, and everybody that's in this column that contains the 4, then what you're left with are the values for your determinant, the 3, 4, and 8, 1. Now for the negative 9, first of all, remember you're subtracting, so it's got to be minus negative 9. And you're going to multiply that by the determinant of the values that are left over when you mark out everybody else in negative 9's row and negative 9's column. And so you'll be left with 1, 0, 8, 1. So your determinant to multiply negative 9 by would be 1, 0, 8, 1. And then the last entry is you take the negative 3, the next entry in this column, negative 3, and you multiply it by, wipe out its row and wipe out its column and see what's left, and you have 1, 0, 3, 4. So that's the determinant that you would use there. And you already know how to do the determinants. This would be 4 times 3 minus 32, which is 4 times negative 29. This would be minus negative 9, which would make it a plus 9, times 1 minus 0, which is 1. So you'd have 9 times 1, which is 9. And then this would be minus 3 times 4 minus 0, which would be minus 3 times 4, which is negative 12. And then if you add those three numbers together, negative 116 plus 9 minus 12, you get negative 119. What's interesting is you can also use the second or third column. So here on this one, I'm going to do this same problem, but I'm going to do it using the third column. So if I use the third column, I would have 0, and then if I mark out this row and this column, I would be left with negative 9, 3, negative 3, 8. So that would give me that determinant. And then if I go down to the 4, and if I mark out this row and this column, that would give me 4, 1, negative 3, 8. And so that's what I would get there. That would give me this determinant, so I'd have minus 4 times that determinant. And then if I go down here to the last entry in the column and I mark out this row in its column, then I'll get the 4, 1, negative 9, 3. And then you can just calculate each of these determinants. And so this one's going to be 0 times some number, which doesn't matter because 0 times a number is 0. And this is going to be minus 4 times 35, which is going to give you negative 140. And this is just going to be 1 times 21. And so you add them together, you get negative 119. So you see, you get the same answer as I did it by using the first column. So basically what you want to do is you want to use the column that's going to give you the determinant of the matrix the quickest. Here's a practice problem. If you want to practice a 3 by 3 determinant, then practice on this one. The answer is given, and then when you're ready you can restart the video. Okay, pause the video here and look at the formula for solving a 3 by 3, 3 equations and 3 variables using determinants, and see how I get these determinants here. I'm just going to go ahead and show you how I solve this problem here. What you want to do first, since x, y, and z, or x1, x2, x3 are all going to use the determinant of the coefficients, I want to calculate the determinant of the coefficients. So 2, negative 2, 1, 3, 1, negative 1, 1, negative 3, 2 is the coefficients. Now, to get the determinant of this, I'm going to take 2 and I'm going to multiply it by, now remember we mark out this row and mark out this column, so I'm going to multiply it by the determinant 1, negative 3, 2. And then I'm going to take 3, but remember the middle term is subtracted, so you have minus 3, and then if you mark out its row and column, you'd have negative 2, 1, and negative 3, 2. Then I'm going to go to 1, so I'm going to say plus 1, and then mark out this row and the column, and I get negative 2, 1, and 1, negative 1. Well, now you just calculate each determinant. That would be 2 minus 3, so that would be negative 1, and then multiply it by 2, so you get negative 2. And then this would be negative 4 plus 3, which would be negative 1, so you have negative 3 times negative 1, that's 3. And then this would be 2 minus 1, and then you multiply that times 1, and you just get 2 minus 1. And if you add these together, you get 2. So the determinant is simply 2. Okay? Now notice that x is dx over d, y is dy over d, and z is dz over d. But notice that each of these matrices or determinants for dx, dy, and dz, they look exactly like the coefficient matrix except for one thing. Wherever the variable would normally be, wherever its coefficients would normally be, we put the constants. So for dx, instead of the x coefficients, we put the constants, d1, d2, d3. Here, for dy, in the middle where the y would be, the y coefficients would be, we put d1, d2, d3. And for dz, we put them in the last column, for d1, d2, and dz. So what I would have here for dx is I would put the constants here, and then the coefficients of y here, and the coefficients of z here. And I'm going to leave you to calculate that determinant. For dy, I would put the constants in the middle column, and then the coefficients of x in the first column, the coefficients of z in the last column, and then I'll leave you to calculate that determinant. And then for dz, I put the constants in the last column, and then the first column would be the coefficients of x, and the middle column would be the coefficients of y. I know I'm saying x, y, and z, and even though it says x1, x2, x3, but I think you get the point. All right, so now if you calculate each of these determinants, you should get 4 for dx, 0 for dy, and negative 2 for dz. Now, so x is dx over d, so that's 4 over 2, which is 2. Y is dy over d, that's 0 over 2, which is 0. And then z is dz over d, which is negative 1. So the solution is 2, 0, negative 1. Now you can pause the video and work this practice problem if you like. But that's it. That's the end.